Hello, welcome to Dora Bhai family. Last lecture we have studied about gauge. Now today we are going to study about Coulomb gauge or transverse gauge. We also call it as transverse gauge. So let's see. As we know that Maxwell's equations, there are terms that is scalar potential and vector potential. Scalar potential is phi and vector potential is a bar. So for scalar potential and vector potential, we have studied some equations. So we are going to write down those equations. That is delta square a bar minus mu epsilon naught del square a bar upon del t square minus delta of delta dot a bar plus mu epsilon naught and del psi upon del t is equal to minus mu j bar. I think this is one of the equations which we have studied. Okay. Now the next equation is delta square phi minus mu epsilon naught del square phi upon del t square plus del by del t del dot a bar plus mu epsilon del phi upon del t is equal to minus rho by epsilon. This is the second equation which we have studied. Now we have these two equations, these two Maxwell's field equations. Now let's apply a Coulomb's gauge condition. Now what is Coulomb's gauge condition? So applying Coulomb's gauge condition. So our Coulomb's gauge condition is that delta dot A bar is equal to 0. Let's apply it in equation 1 and 2. First apply it in equation 1. What will we get? We have delta dot A bar is equal to 0. That means our this quantity is going to get 0, right? So what will we get? Let's write it down. Delta square A bar minus mu epsilon naught del square A bar upon del t square minus mu epsilon naught. This value became 0, that's why we didn't wrote it down. Delta del phi by del t is equal to minus mu j bar. Now let's transverse this equation over on this side. We'll get delta square A bar minus mu epsilon del square A bar upon del t square is equal to, on this side it will become, it was minus, it will become plus. So we'll get mu epsilon delta del phi by del t is equal to, not equal to, we'll write it down here as minus mu j bar. So let's denote this equation as equation, no, we have already did equation 3. This is our equation. So this is what becomes of equation 1 when we apply Coulomb's gauge condition. Now let's apply the Coulomb's gauge condition in equation 2. So applying delta dot A bar is equal to 0 in equation 2. What will we get in equation 2? Here, this value will become 0, right? And the remaining value will be as it is. So, delta square phi minus mu epsilon del square phi upon del t square plus. Now, if this value becomes 0, this will get multiplied inside. And if this will get multiplied inside, we'll get del square phi upon del t square, right? So, let's write it down. Mu epsilon as it is, del square phi upon del t square is equal to minus rho by epsilon naught. Now here, this and this values are same, they will get cancelled. What will we get? Will be remaining with del square phi is equal to minus rho upon epsilon. Let's consider this equation as equation 4. So this equation is representing the Poisson's equation. This equation is known as Poisson's equation. This equation represents Poisson's equation. So there is a particular solution for this equation. We have this equation that is del square phi is equal to minus rho upon epsilon. There is a particular solution for this Poisson's equation. So solution for equation 4, which is phi of x alpha t, these two are coordinates, is equal to 1 upon 4 pi epsilon rho x dash alpha t, these are also coordinates, upon r closed integration. This is integration dv dash, that is volume integral, where x alpha t are coordinates. So how, actually which coordinates are there? Let's consider we have 2 points. One is our source and one is our field. One is our source point and one is our field point. So for field point our coordinates will be x alpha t, and for source point our coordinates will be x alpha dash t, and distance between this is r. Distance between these 2 points is r. So when we want to calculate between these 2 points or the coordinates of this point, we use Poisson's ratio or we use Poisson's equation. So we'll write it down that what exactly are all the terms. So first of all, x alpha t are coordinates of field point, coordinates of field point, that is f, coordinates of f, and x alpha dash t are coordinates of source point, that is S. So what exactly are F and S? F is field point. Field point means from where we have to measure the potential. We are measuring here potential, no, scalar potential and vector potential. So F will be the field point. Field point is where we have to measure potential. And S is our source point, where field is produced, where field is producing, and due to that field there is particular potential at point F, and we are measuring the potential at point F. We are measuring vector potential and scalar potential over there. So this will be our source point, not the field point. Source point where field is produced. Here our field is getting produced and R is distance between F and S. So R is the distance between F and S. Now dv dash will be, let's write it down here, dv dash will be any arbitrary volume element, any element, okay? So any arbitrary volume element at source point, that is at S. This will be our volume element. So can we write it down as phi is equal to 1 upon 4 pi epsilon rho upon r integration dv dash. This is how we can write it down. Let's consider this equation as equation 5. So here we have taken the current density. From here we have to calculate the current density. What we got today, we got the value of this. We got the value of second equation, that is how to denote second equation helping Coulomb's gauge condition, and how to denote first equation using Coulomb's condition. This is our second equation, and We have studied that what is field point, what is source point, and after that we are going to study that how to calculate current density using all this. So that we are going to study in next lecture. Thank you for watching the lecture.
अरे एक मिनट, देख लिए, पसंद आया वीडियो? तो ऐसे ही और इंफॉर्मेटिव वीडियोस को देखने के लिए आज ही हमारे एप्लीकेशन डोरा भाई को डाउनलोड कीजिए प्ले स्टोर से, जहां हमारे एजुकेटर्स फ्रॉम टॉप इंस्टीट्यूशंस और आईआईटी से आपकी यूनिवर्सिटी के हिसाब से लेके आए हैं क्यूरेटेड वीडियो लेक्चर्स और वाइड वैरायटी ऑफ नोट्स बिल्कुल फ्री ऑफ कॉस्ट। तो देरी किस बात की, आज ही हमारे और आपके डोरा भाई को डाउनलोड कीजिए प्ले स्टोर से और एग्जाम में फोड़ दीजिए।